Thank you very much for joining us today, and welcome to this webinar, How to Realize G3 PLC Smart Meter Interoperability in the Field. I'm sure all of you know in general the benefits of interoperability, which include reducing supply chain risk, avoiding vendor lock-in, and in general reducing the costs. Open standards like G3 PLC with a strong certification program are fundamental to realizing interoperable multi-vendor solutions. And the webinar today will discuss how you can realize interoperability in the field. So what is in general the approach to do this, and how did utilities like Enedis from France and EVN from Austria successfully achieve interoperability and also manage the complexity to reap these benefits. So that's the topic for the webinar today. And to answer these questions, I'm really pleased we are joined today by a few experts in this field, from consulting company Trialog from France, and people from the utilities Enedis and EVN, who have hands-on experience with meter interoperability from their rollouts in France and Austria respectively. So very welcome to Olivier Genest from Trialog, to Joseph Vroehalf and Abdallah Touil from Enedis in France, and Nicole Gugurel from Netz Niederösterreich in Austria. They will all briefly introduce themselves when they start their presentation in the webinar. So that will follow later. My name is Leon Vergeer. I'm the General Secretary of the G3 PLC Alliance, and will kind of host this session today. Most of the people I know are, most of the people in the webinar today are familiar with G3 PLC. So I will only say a few words about G3 PLC before starting the topic of the interoperability. So G3 PLC is a proven power line communication technology offering the lowest total cost of ownership and independency on telco operators. It's a very cost-effective communication, as the utilities and other end users use their own infrastructure for communication. G3 PLC provides robust communication. It's an international open standard supporting end-to-end IPv6 connectivity. G3 PLC was developed for smart metering, and it's still mainly used in smart metering, but also in a growing number of other applications. You can see on the right, these include, for example, street lighting, grid control, home automation, smart railway stations, and several other applications. G3 PLC is a mature technology. There are over 80 million products in the field in more than 30 countries all over the world. G3 PLC is backed by an international group of nearly 100 DSOs and industrial players, including all major meter manufacturers globally. And like I said, G3 PLC is an international open standard, and we have a very strong certification program. The specification is published by ITU. And in the graph, you can see that since the opening of the certification in 2014, we have now already certified over 500 devices in 4 different PLC band plans. From the bottom, it's ARIPE, the frequency used in Japan, Senelec A, FCC, and also Senelec B band plan. In 2020, the G3 PLC Alliance introduced our hybrid solution, which combines PLC and RF communication in one single solution. And in this hybrid, each device can use PLC as well as RF for the communication, And for each individual link in the network, the best available channel is selected automatically and adjusted dynamically based on the actual conditions in the grid at any time. So, and the hybrid solution is also included in our certification program. And today you can see we already have 28 certified hybrid devices from 5 different chip manufacturers and already from 3 product manufacturers till today. So that's a short introduction to the topic and a short introduction about G3 PLC. Then the agenda for today: first, Olivier will present a general approach to achieve interoperability, and then following that, Enedis and EVN will share their experiences. After that, there should be time to answer any questions you may have. The webinar is planned to last 1 hour in total. It will be recorded, and we will share this presentation with all the attendees after the webinar. So that's for the logistics. Then Olivier, I'd like to hand to you for the first part of the presentation. Let me give the controls. Let me make you presenter. There you go. You should be able to share the presentation now, Olivier.
Yes.
Good.
Should work. Okay, thank you. So good afternoon, everyone. So I'm Olivier Genest. I'm from Trialog. I'm involved in smart metering program since 2008, and I've been involved for more than 12 years on G3 PLC communication standard. I've been involved in G3 PLC Alliance to set up interoperability from the beginning, and also a certification program. And I've also supported several DSOs in Europe for interoperability of smart metering and smart grid system. So what I would like to share today is a general approach to achieve interoperability. So the starting point for that is what is interoperability? So we have a definition here where interoperability is a characteristic of a product or a system to work with other product of system, and it is based on open standards. So we can see several degrees of operability, and we can see on the left part where we have a higher integration effort, because each time we have a solution that we need to adapt to each other. So that's the case of compatibility, meaning that we have different product or systems that we need to adapt to each other. And when we go to the right, we have an open standard, which is a reference. And this is where we have the interoperability, and each of the solutions just have to implement the open standard. And based on that, they can operate all together. And in between, we have the case of de facto standard, meaning that one solution becomes the reference, and all the other solutions are adapting to this reference, which is not, in fact, an open standard, and usually come from one manufacturer and one solution from the beginning. So we have these 3 levels, and really what we want to reach is the right side where we can really lower the integration effort. We also have to consider that we have several layers of interoperability, and what we are describing here is called is based on the GWAC interoperability framework. So on the bottom side, we have the most common one we are talking about, which is technical interoperability, meaning the connectivity, the network, how different devices are able to understand each other at the protocol level, how they are able to connect, and they use the same syntax to exchange some packets, and we'll have the same way to encode the bytes and everything. But on top of that, after exchanging some data, they need to understand the data the same way. So that's the informational interoperability. So they have to share the same semantic and also the same business context. So what is the meaning of this information, and what this information means in the context that we have. And finally, there is also the organizational interoperability, because this information also goes into a larger business process, and we need to take that into account together with the regulatory framework and what are the business roles and what are the actors and what are the functions we want to achieve. And so we need that all the actors and components that we have in the system, they understand the business objective the same way, they understand the business processes the same way, and so finally they can achieve the business services that we want to have. So when we talk about interoperability, we really need to cover all these three items, because if we have only like technical interoperability, meaning that, okay, we have, I don't know, like several ZigBee devices that are able to talk together, but finally the data doesn't mean the same thing, nothing will happen. And even if the data can be understood, but the function doesn't mean or are not consistent, then we will not achieve what we want to do, meaning we want to achieve our business objective with some specific functions. Also regarding interoperability, we have the case of interoperability and interchangeability. So interoperability means that two devices can work together and can understand each other. That's what we discussed first. Interchangeable is something different. It means that one device can be replaced by another one and offer the same function, meaning that we will not see any difference. And we can see in the case of a smart meter that a DC data concentrator and a meter, they are interoperable because they can understand each other. However, they are not interchangeable because you cannot just replace a meter by a DC. Just a case to understand the difference. So if we look at this concept of interoperability in a smart metering system, we can look at these three levels and what we will have. If we start from the top, from the bottom, sorry, we have the technical part, which can be like G3 PLC protocol, DLMS COSM protocol, and informational model level. We can have this data model, and after we have the function system use case. So starting from the bottom, we have like a data constructor and a meter. They need to understand each other. And like if they are using G3 PLC communication protocol, we have to check the technical interoperability between these two protocols. And also we can have other meters because, as you know, G3 PLC is using routing, meaning that when the DC wants to communicate with the meter on the right, the signal has to go through another meter. So we need to achieve interoperability between the data constructor and the first meter, but also between the first meter and the second meter. Then on top of G3 PLC, we are also using IP and UDP protocol to transfer the information, and also DLMS COSM application protocol. So we also need to check the technical interoperability of the DLMS COSM messaging protocol, meaning how we are reading or writing objects. And similarly, we have a protocol which is used to enable the data constructor to connect to the head-end system, which will be part of the information system and will enable the data constructor to get connection with the smart metering information system. On top of that, once we have the connectivity, we will now have to be able to exchange data. And for that, we have a data model that describes all the data that we have inside the meter. And this data model will have to be interoperable between the meter, in this case, and what is described inside the data constructor. So the data constructor can retrieve the information from the meter and use this information so it can be provided to the information system. And then we can see we have the second data model. So this information retrieved from in the data constructor can be like analyzed or computed and then provided to the meter data management system through another data model. And in this case also, we'll need to have this interoperability between the DC and the MDM. And on top of that, each of these components will have some function. Like in the meter, we'll have some function that will support disconnection or will support some prepaid behavior. Or in the DC, we'll have some collection of the indexes or some transfer or some action to open the relay or something like this. And all these functions, they have to be consistent and they have to be part of the same business process. And this is the organizational interoperability that we need to have through the whole system. So we see how in this smart metering system, all these three layers of interoperability are important, and they are part of several interfaces, and they are spread all across the different components of the system. So now that we see all this interoperability and where we can find this in a smart metering system, we also need to understand, okay, where should I focus? What are really the interoperability challenges that I will have in my smart metering system? Because depending on my system procurement strategy, probably I will have some part of the system that will be highly challenging and some other that will not. In particular, because we all understand that in case I have the same provider for several components of my system, the interoperability risk is quite low, because I mean, they will have the same understanding of specifications, they will provide the same probably protocol stack for both parts or the same data model, and finally, they will be able to communicate together and understand each other and have the same functions. But in case we have several actors, of course, it becomes more complicated if we have two. And if we have three or more, it's becoming even more complicated, because then we have to make sure that it's not only two people who understand each other, but that everybody agrees the same way. So we have to consider that to see where is the highest challenges. So on the bottom, you can see several examples of system procurement strategy for smart metering. So on the left side, you have the case where you have like one supplier for the HCS, Helen system, and meter data management. So you have all this information system provided by one supplier. And then you have a data constructor provided by different suppliers, and also the meters provided by different suppliers. And you are mixing this data constructor and meters. So in such case, we see that we will have several challenges. One of them being the interface between the Helen system here, and the other one being the one between the meter and the data constructor, because we'll have interoperability between the meter and between the meter and the DC. If we go to the next one, then it's a little bit easier because in this case, the DC provider is the same as the head-end system provider. So the interface between the DC and the head-end system is less challenging, and most of the effort will have to be put between the meter and the DC and between the meter themselves. Or we could have a system procurement strategy in which we say, okay, I will not mix several manufacturers in my network, meaning that I will always have the same manufacturer from my DC and for the meters that I will put on the same network. So in this case, we will have interoperability mostly between the head-end system and the DC, because we see that we have several manufacturers here and we'll have to connect to the head-end system. And we can even go one step further in which we say, okay, I will not integrate several data constructor into the head-end system because there is too much dependency between these two parts. But instead, I will do integration as part of my meter data management system, and I will just use two different head-end systems that will be fully vertically integrated using head-end system, DC, and meters. And then my integration will be only here. And so interoperability challenge will be between the head-end system and meter data management. And so we see with these different options that there is always a trade-off between design complexity. On the left side, we have a high interoperability challenge and operation complexity. Because when you look at the right side, okay, we have less interoperability challenge, but we have a high dependency on one actor, meaning that if the green manufacturer stops providing something, then we just cannot operate a full part of the system. And also there's a low flexibility, because if you need to change something on the grid structure, you will have to change the meter also, because part of the LV network will now be connected to another DC. Or also it means that you will not be able to take any meter from the stock and put it everywhere. You will just have to always make sure that you put a meter that is the same as the one of the DC. At least it will make the operation very much complex. So it's always a trade-off, and this has to be taken into account. So now let's have a look at the methodology to put in place. So in general, to achieve interoperability, we need to go through three main steps. The first one, which is really important, is the specification. We need to specify, but not only specify, also reach a common understanding. So specification is based on standards, but not only, we need to define the profile, we need to define how we will be using the standards. And also, we need to provide some reference samples, we need to provide something that will help people to check that they have the same understanding that is the one that is expected. The second step is that we need to check conformance. We need to make sure that there is a compliance to the specification and to already have a kind of check of unitary interoperability. And for that, it is recommended to rely on independent third parties that will provide external review and also make sure that they can fix in case there is a differences between several implementations. And finally, we need to validate interoperability in a system as a whole and look at function, look at the behavior of the full system, and look at the performance of the system. And in each of these steps, we always need to keep in mind that there is a feedback loop to the specification, because every time we find an interoperability issue, we need to consider improving the specification. So if I look at the first step, specification, so specification must be as clear and explicit as possible. It means that first we need to select the standards to be used. Like, okay, I will be using G3 PLC, I will be using DLMS COSAM, and then we need to define the profile, or sometimes it's called the companion specification. It may, inside we will make explicit which part of the standards are mandatory and which option parameter must be used. Like if I take DLMS COSAM, I can use short name or logical name in the way I will call the object. Or if I use like G3 PLC, I can decide to use, I don't know, like FCC band or select A band. Or if I use, I can decide that I will some specific tone mask, or I will decide I use with some specific parameters for routing. Anyway, I can decide some option. And also, we need to define the upper layer mechanisms. Like if you look at the G3 PLC specification, we describe how the bootstrapping is done, meaning how a device does to join a network. But it is not described how the device triggers the joining of the network, how the device decides that it has to start scanning for a network. And this is part of the upper layer mechanism, because the application of the smart meter has to start and say, okay, now you will try to find a network, and now you will launch, you will join this one. And this part has to be defined, and it's part of this profile or companion specification. So that's something that needs to be defined. And for that, we have also some interesting guideline and white paper within the G3 PLC Alliance that can help you to build this profile. Also, there have been some work done by some other alliances like Enedis Association in the past, and now DLMS UA worked on profiles for DLMS COSAM. So there are some work done about this profile to help. And it's a good starting point, but also based on what features you want to achieve, you need to really say, okay, how you want to use the existing standard that you will be using. Also, this interoperability requires not only the specification, but to make sure that everybody will reach a common understanding. And it means that everybody will understand the specification the same way. To check that, we can share reference samples. So a reference sample means that if we talk about technical interoperability, it can be a test vector. So a test vector is an analog digital frame that we use to check that several implementation will generate the same frame or will decode the frame the same way. So make sure that the encoding and decoding is exactly the same. If we talk about informational interoperability, it could be a data set. If we talk about organizational interoperability, it could be a simulator that will simulate the behavior of the function. Or also, in the case of technical interoperability, we can use organized plug fest or integration fest, in which we connect implementation together to check that they understand each other. in case we find any gray zone or ambiguity, we know that it leads to interoperability issue. So this needs to be tracked and fixed continuously. Each time we find this kind of issue, we really need to fix it. The second step is that we need to check the conformance. So conformance testing, the objective is to check that the component correctly implemented the specification. So we have unit testing, meaning that for each statement of the specification, we'll have only one test. And in fact, we'll have one test for the valid case, and also we'll have tests for the invalid cases, like if I have a packet that is not expected, what is the error message that is sent, or what is the behavior that is done. Also, these conformance tests are based on the specification, and it is also a good way to challenge the specification by making sure that we have a clear verdict for each of the cases. I mean that the specification clearly states what is expected and what is not acceptable. This kind of conformance tests usually rely on automated test tool because we have hundreds of test scripts. And also we may include some basic integrated tests like to check like that several devices can understand each other for some specific protocols, for example, or some data. So for this part, it is recommended to rely on interoperability on independent third party, so not one of the suppliers, because it is neutral in case of interoperability issue or in case there is a disagreement on how to implement part of the specification, and also because it brings another perspective to the project. Like if you have two implementers and you want to check interoperability, this third party provides kind of third view. So now you have like three implementers making sure that, okay, we all three have the same understanding of the specification, the one who wrote the test and the two others who implemented the device. And for this part, many alliances or associations provide certification programs that will cover conformance testing for some specific interfaces. So it will help you, for example, to check the technical conformance, so the conformance for the technical interoperability of G3 PLC, or for DLMS, or for some specific data model like SIM, CGMES profile, something like this. And the third step is now to validate interoperability at the system level. So this is part of the system integration, and the purpose is to look at the interoperability of each interface as one-to-one or one-to-many, meaning that we just put two components together or one component with many other components. And we look at what is the impact of interoperability on the function. So we need to make sure that we are able to achieve the function. We need to also check that interoperability does not impact the performances negatively. And also we may need to make sure that the interoperability does not reduce the scalability. And in this part, we need to consider the system as a whole, meaning that this system function, they involve components and different layers. So we need to keep this dependency in mind, meaning that we need really to make sure that when we look at how it behaves in general, we look at how each of the components behaves, and if we find any discrepancies, we need to look into details about what goes on each of the interfaces. The final goal is to achieve end-to-end interoperability, meaning the full system is working all together to achieve the system function. And it is very useful when possible to build the system iteratively. And so starting to work on the first system, so in the case of smart metering, very often we start with working on DC to meter and only. And once this part between DC and meter works well, then we connect the HES and MDM, so we can reduce the complexity and really ease the debugging by looking only to the part of the system at the beginning. And finally, we have this feedback loop that I already mentioned, which is its continuous improvement of the specification. So at every step, the cornerstone of the interoperability remains the specification. So if there are different ways to understand specifications, there is always a risk that there will be different way to implement it. And so this specification should be really a living document, and not only during the starting of the project, but during the whole duration of the project, we need to really always update it. one option is to maintain and publish in parallel FAQ, frequently asked question, in which we clarify what is expected understanding, so we avoid any ambiguity, and sometimes we release a new version of the document. And also we can improve the conformance test every time we find an interoperability issue. So really, the purpose here is to make sure that every future device will reduce the risk of interoperability. So that's my conclusion about the 3 steps and the feedback loops to be considered. And I will hand over to you, Léon, to go then to experience from our DSO of this methodology.
Yeah, thank you very much, Olivier. Let me take back the screen. So thank you very much for this generic approach to interoperability. If anybody has any questions, please post them in the question box on your control panel. Then we can address these questions maybe during the presentations or at the end when we have some time for discussions. Then, following the generic approach, I'd like to go to the experience from Enedis first. So please, Abdallah, Joseph, please start your presentation.
Yeah, so hello everybody. Yes, so I am Joseph Riouf. I joined Enedis in 2014 for the Linky project, and my function basically was to be sure that the manufacturers are ready to go for our tenders, especially for the specific functionalities that we had in the Linky project. And one of them, of course, is a PLC G3. Okay, and Abdallah, together with me, is the team leader for the PLC team. So I will give you some short information about the Linky project in France. So Enedis, we are the main DSO in France, and we had to go to smart meters with some discussion and thoughts beginning before 2010. And the first idea was to use some outsourcing competencies, so to ask somebody to fully perform the project for us, and this is how we ran the first pilot, with some results which were not so good. So in 2014 or a little bit before, we decided to do it all by ourselves with our own specifications, and we ourselves dealing with the manufacturers and dealing with the tests and so on. Okay, so we achieved this, we had some tenders and so on, and we started to deploy the Linky project or the meters on the field in 2015. And it's the rollout lasts until 2021 for the mass rollout. So it's almost finished now, and we have some remaining meters to be deployed on the field, but we have already 35 million meters there and more than 700,000 data concentrators. Can move to the next one. So some figures, meters and concentrators, I said. So it lasted for 6 years. The initial budget was 5 billion euros, and we managed to be a little bit below, which is good. We worked with 6 suppliers for meters and data concentrators, and we achieved quite good figures with 98% of daily collect success rate, which is good towards what the regulator is asking us. We also match, of course, cybersecurity requirements and regulatory constraints and so on. I'll move to next. So, as I said, we had 6 manufacturers. You can see the names here, and also 2 types of devices, meters and data concentrators, and 2 versions of the Alliance specifications because of the time going on. So the 2015 and the 2017 versions. So all this makes a lot of diversity and possible combinations. So we had to be sure that at every level, especially once we put something on the field, that everything works well. And so interoperability is, of course, one of the main issue, because we basically are in the model of the left, if you remember the models that Olivier showed. So with interchangeability, and we can put whatever DC and whatever meter at whatever place. So we have to be sure that everything works together fine. Yeah, we can go to the next one. Okay, so how did we achieve this? So basically, we followed what Olivier was describing. I hope he will give us some good rate. So of course, the first step was the specification. So we issued our own specification, but of course, based on standards and on the G3 PLC Alliance specifications. And we asked our 6 manufacturers that all the equipments and softwares, because we had several software versions, are certified by the Alliance. Okay, so this is the first level, but as Olivier said, it's only the first level. Just the specification is not enough. Then we performed in our laboratory in Nanterre near Paris. We performed all the tests that you can see on the left of the screen. So first the unit test. So this is to ensure that each device and each firmware is okay according to our specification. So basically we did this test with one data concentrator, or one reference data concentrator, and 1 meter. And we can also do the opposite for testing the data concentrator. Okay. Then of course we put together several kind of meters with one data concentrator, from 9, for instance, up to 200 meters, to start checking the interoperability. So we could mix all the meter and the data concentrator manufacturers, versions, hardware versions, software versions. Also, we had some 3-phase meters, some single-phase meter, so a lot of diversity, and we have the possibility to put all that together and to continuously check that everything is fine. With some test list to be performed on all of those combinations. Then we also had a stress test. So letting this kind of a diversity, so the same numbers for the DC and meters, but letting them run for a longer time, still in the lab, to check if after a week, a month, 2 months, everything is still fine, because as you know, sometimes the software can go in some unexpected state, or the hardware also can have some issues after some time. And at that stage, we can say, okay, the lab tests are finished. We are now able to go on the field. And also this field test is progressive. So we start first with a small part of the field, then a bigger part, and then we say, okay, we can put this version or this hardware on the whole field without limitations. Can go to the next slide, please. So how do we do that? What tools do we have? So again, we tested more than 47 products since 2019, and for that we used more than 3,000 tests, mainly automatic, for the meters, and 1,700 tests for the data concentrators. So to do that, we have some tools. For the one-to-one test, we have the bay on the left, bottom left of the screen, which is duplicated, and we have 90 test bays like that, which are automatically managed by 30 computers, and a dedicated tool that we developed, which is called Linkimat, to organize and run those tests. Okay, so this is for the unit test. Then for the interoperability and robustness test, we have a bigger base, bay test base, sorry, which can manage up to 200 meters, and you have some sample behind Abdallah on the video, and also on the picture. And then for the field test, as I said, we start with only one place, so one data concentrator and the meters around. If everything is well, we go to 20 and then to 100, and then we consider that it's okay. But still, we don't just put the firmware on the meter all over the field. We limit from 50,000 to 50,000 to be sure to detect any issues that could arise immediately and stop the deployment of this firmware or hardware. So as you can see, everything is very progressive so that we can react immediately together with the manufacturer if an issue is found. Next slide, please.
Yeah.
So we are asked to list a little bit the issues that we could face. So we listed two. One of them is the end of support by some chipset manufacturer. We just didn't support G3 PLC anymore. So at that time, we were happy to have several manufacturers who had several chip suppliers to be sure to continue deployment, or at least at a slower rate, but to continue. During the time, we can find some solution. Okay. Second issue is, as Olivier said, we have some gray zones in the specifications, which opens some interpretation possibilities. So we face that for the algorithm computing the SNR, for instance, and we observed that some routes were going always through the same meter because this one was a little bit optimistic. So the route was probably not the optimal one, so this could give lower performances. Okay, so this subject was raised, and we have to discuss about it and so on. Okay, then two recommendations for colleagues of DSOs. So of course, it's good to be part of a G3 PLC Alliance or other standardization committees to have a lot of information to be able to use standards and so on before writing our own specifications. So don't hesitate to attend or to ask help from those people. And last recommendation is don't forget that what is not tested does not work, because we've seen that a lot during our project. Thank you.
Thanks very much, Joseph, for this clear experience from Enedis with the many interoperable devices. I understand. So if anybody has a question for Joseph or Abdallah, please share them on the question box, then we can address these questions. But maybe first let's go to Nicole to share the experiences from EVN in Austria before we go to the questions.
Yes, hello also from my side. Just for the beginning, I can give you a short update about the situation in Lower Austria. So in our company, we have to install 844,000 pieces of smart meter. This is our goal. We have started the rollout in September 2020, so 2 years ago. At the moment, our rollout status are over 800,000 smart meter, which means 95% are already reached. This was also our goal for September 2022, so we are very good in our plan. We have an overall opt-out rate from 4.7%, and we have a daily reading rate about 99.3%, which is very good, and we're very happy about it. This is the situation. And please, the next slide. I can give you a short overview how we realized the interoperability topic in our company. So we have around 844,000 meters, which means 90% polyphase and 10% single phase meters. Our goal was the interoperability for meters and the DCs, which we used with a two-supplier strategy. Also to reduce the technical and commercial risks, so means hardware, firmware errors, or the commercial risks, also delay in the production or other delivery difficulties. At all, we have to say that 100% meter delivered within the 24 months. So also there we are very lucky. The two supplier strategy is a compromise between cost and risk. This was a decision, what also means that costs are incurred because of this decision, because you have to develop two different meter types with the companies. When we go to the next slide. Thank you. How did we achieve the interoperability? First of all, we have a lot of technical specification based on the international standards. Maybe you know the 4 points which we mentioned here. This is first electricity metering data exchange model. That means DLMS COSAM communication. We have the G3 standard specification and G3 certification. We also have the 4 colored books for the DLMS user association and the security concept, which is state of the art. And over all these standards, we have created a companion standard in our company, but not on our side. We developed this with the best bidder from the tender of the meter, DC, and head-end system. So this bidder was responsible to create the companion standard and to close all the gaps between the different suppliers. We have 3 different companion standards. And the first one is the companion standard implementation guide, which has 59 pages. And for example, you find there the system architecture, the meter functionalities, and so on. And then we have the companion standard object model, which is an Excel with 1,603 lines. There are included all the OBIS codes, all the different accesses which you get the objects or just only allowed to read the objects and so on. And we have the companion standard display guide with 20 pages. Our goal is to really have 2 different meters, but looks nearly like the same. Also for the customers, that is easier, and that everything works fine in the infrastructure with our head-end system and the meter data management system. Can you go to the next page, please?
Yeah.
Yes. So I mentioned already a G3 PLC certification by the G3 PLC Alliance. The DC and head-end system supplier was responsible or is responsible that each meter type fulfills the requirements of the specific companion standard. He has also the responsibility to test all the different meter types in his lab, also in combination with the head-end system, to take sure that everything is working. And for that, he also have to guarantee 100% compliance. But at all, and I think Joseph mentioned it, also on our side, we have done parallel tests, which are very, very necessary. For our point of view, especially one was a data model. That was the highest important point, that we test the 1,603 lines in the Excel if the meters are compliant with this. We also have done some security tests by an independent testing institute. And we also had feed trials with 400 meters before we start the rollout in Lower Austria. When you go to the next page, please. What we have learned or what we faced during this process, the development of a companion standard would not have been possible without external support. In our position, you need a really detailed knowledge about the individual objects and standards, and also the DLMS COSAM communication. And without the external company, it would not be possible in that way. What we can recommend for other DSOs, just look for a partner who have the know-how, but not rely only on third party. Just take sure that you build up your own personal stuff and the knowledge during the project time. Yes, and this is our input for the meeting today.
All right, thank you very much, Nicole, for your presentation.
Thank you.
I've seen a couple of questions coming by. Some are very specific, so we may better address these offline. But one question, Nicole, I think is addressed to you basically. The question is, when you talk about 99.3 daily reading rate, which amount of data are you talking about for each meter in bytes? Is that a question you can easily answer?
Not easily in bytes, but I talk about the 24 hours profile. So means one value at midnight from each meter for 4 channels. Yeah. But I can maybe ask the colleagues if you need the size of the data.
Yeah, so Giuseppe, if that answers your question, if it does not answer your question, please please let us know, and we can try to find some more specific details and come back to you about that. But I think that broadly describes the type of data being gathered in EVN. That completed the presentation. So if you have any further questions, please post them on the box, and we will take a look and try to answer them as good as we can. But before going to the questions, to conclude, I would want to say G3 PLC is a standards-based technology with a strong certification program and support, enabling interoperable multi-vendor implementations in the field. We mentioned the benefits of interoperability in the introduction, reducing supply chain risk, avoiding vendor lock-in, reducing cost. And Olivier explained that interoperability can be introduced at different levels, at the head-end system, at the DCs, or at the meter level in the system, depending on the procurement strategy of the utility. And this is always a trade-off between complexity you want to introduce in the program to realize the interoperability on the one hand, and the complexity in the operation after the rollout on the other hand. I think the presentations from Enedis and EVN they show different approaches depending on the strategic choices of the utilities. Do you choose to develop all the capabilities you need in-house, or do you choose to rely more on external partners, meter providers, for example? Interoperability is not really easy to realize, but Enedis and EVN and many others clearly show it's very well possible to realize in the field. And other certifications like IDIS, the LMS, for example, they cover the upper layers and metering use cases, can also reduce the complexity for the utility here. So G3 PLC Alliance is there to support you with your projects. We have a certification for G3 in place. There are other certifications like IDIS, the LMS. We have the tools, the test tools to support the end users. We have many very experienced manufacturers in the Alliance and DSOs like Enedis, EVN, and many others. And we have other members like Trialog who can support you in your projects. And that support can, for example, be sharing experiences between utilities. It can be training, it can be testing, or expert input for specific questions. So please do not hesitate to contact me or any of the presenters if you have any further questions. You can find the details in the presentation. Then let's take a look at some of the questions. A first question, maybe for Joseph or Abdallah. You explained about the testing you did with the rollout, but how do you manage interoperability with future generations of the meters? Can you say a few words about that?
Not sure to understand really the questions, because what is the future generation? Is it within 10 years, or is it the one which we will
Oh,
put tomorrow?
you mentioned in your slides you currently use 2015, 2017 specification. There already is a newer release in the G3 PLC Alliance. I think the question relates to these evolutions in the specification.
Okay, so basically the specification for this G3 is mainly backward compatible. So this helps us to have new meters compatible with what is already on the field. And of course, as I said, for every new software and so on, we perform the same tests, mixing everything together within the lab. And so we won't put on the field a meter which doesn't go positively through those tests. And we also are part of the G3 PLC Alliance. And this helps, of course, to be sure that backward compatibility is there.
Yeah, all right. And of course, maybe you already mentioned it, but of course, all developments in the G3 specification are always backward compatible. So in theory, there should be no issues, but of course, that needs to be very well tested. We have some other interesting questions coming up, I think. One other question, why would you develop, or why did you develop your own specification and not use Enedis, for example? Is there anybody who would like to say something about that?
Well, for Enedis, it was basically, I was not there, but as far as I know, it was basically because we already had some electronic meters on the field with some specific items which were not easy to describe, even with all what the DLMS COSEM allows. So we had to imagine some little tunes to be sure that everything what our customers already are able to or used to be sure that this is still available with the new meter. So this is one of the reasons we wrote our own specification. So backward compatibility with our previous generation of meters.
I see, yeah. Anybody wants to add to that? I'm not an expert in the Enedis specification certification.
So for sure, in Enedis, there are some use cases being defined and some specific features. And sometimes, so this is really useful as being a basis, but sometimes it doesn't cover all the use cases that a DSO wants to have for its smart metering system. So in such case, there is a need to specify something else. Like I think also, Leon, for example, you had the experience of smart metering in the Netherlands, where there was some national specification for the use cases and the function that were defined and had some very specific requirements. And Enedis defined both the use cases and the function and the data model with DLMS COSEM, and also all the DLMS protocol and the G3 PLC protocol, for example. And even if the G3 PLC and DLMS protocol would be interesting, if the use case and function are not aligned with what you need, then you still need to define something for your need.
Yeah, I recognize what you say, Olivier. And of course, Enedis is constantly being developed. And now that Enedis merged with DLMS User Association, there are developments ongoing in that area as well in the DLMS organization. Another question before we have to close, because I think it's already 3 o'clock, I see. The question is, which HES systems are being used by Enedis and EVN? Is that something you can answer, Abdallah, maybe for Enedis?
Now, at Enedis, we develop our heading system, and we added the other specification also over the G3 PLC alliance specification, and we use we developed our specific heading system. We didn't use, for example, a manufacturer system, hidden system, in order to control and manage our meters and the data concentrator.
Yeah. And Nicole, is there something you can say about that? I think you briefly touched on the topic already in your presentation.
Yes, from EVN side, we use the Siconia suite from the company Sagemcom for the head-end system and the metadata management system.
Yeah, thanks. One last question, maybe before we have to close the session. Maybe Joseph or Olivier can help with that. The question is the PLC performance of two different vendors? Does it really have to be similar to reach the goal of interoperability?
Basically, yes. We've seen during the qualifications that some differences could appear, and then we asked and worked with the manufacturers to reach some, perhaps not exactly the same performance, but some similar performance, so that everything goes fine on the field.
And in the same question, Olivier, it's always also asked regarding all the relevant PLC parameters, should they be harmonized or not?
So it depends. It depends on the parameter. So, but for many of them, they need to be the same value. So the behavior is the same for the whole system. But for that, maybe the main best reference for that is that there is a user guideline that has been developed by G3 PLC Alliance, and for each of the parameters, explain how they should be tuned or used, and which of them needs to be the same for everyone, and which of them can be fine-tuned in specific case, and how they should be used.
Yeah, that's a good point. We have several user guidelines available on the G3 website. Some of them are available to anybody, and some are available only to members of the alliance. And there are a few of them addressing topics like this, so that's a good place to look as well. So I think we have to stop here because of the time, but if you have any further questions, then please, like I said, contact any of us or me online to get answers to your questions. I want to thank, first of all the presenters for sharing their experiences, taking the time to make a presentation, and taking the time to participate in the webinar today. And next to that, I want to thank all of you attending this session today. I will share the presentation. We will make the webinar recording online, and the questions we could not answer, we will do so directly by email. And if you have any further questions, then please contact us by email as well. So thank you, and goodbye to the next time.
Bye-bye.
Bye-bye.
Bye.